Hello everyone, my name is Yang Ye. Student ID is 240071607. My FYP project is DocuGuard, an enterprise-grade building intelligence platform for Hong Kong. Today, I will walk you through the project. First, let's look at the view problem the project shows. In Hong Kong, many building inspection is unified, subjective, and very costly. At the same time, building data is the fragment record multiplied government open platform, and with no unified tool to data-driven assessment. So my core goal was to build a complete end-to-end enterprise-grade platform to fix these gaps. This project was built under viewer engineering constraint and not an ideal lab environment. I have a fast FYP deployment cycle and needed to balance the cloud performance and operational costs. I also had to strictly follow the Hong Kong's PDPO privacy regulations and work within government API RAC limit. The biggest technical challenge was the heavy manual workload for the data annotation and the complete spatial database design for the Hong Kong building data. And these project challenges I showed in this project. Here is the end-to-end microservices architecture for the system. This is the production-ready platform, not just the simple model demo. I split the system into 4 core and create 1. Data engineering, 2. Spatial intelligence, 3. AI detection, and cloud deployment. The full stack includes VUE for end, Fast API, API gateway, called microservices, and about the database PostgreSQL with the PostGIS, and the full GCP cloud deployment with the Kubernetes, and about the infrastructure use the Terraform. First, the core part, data engineering. I integrated data from the 5+ Hong Kong government open data source. In total, the system had around 596,000 core records, covering 182,619 buildings. Accuracy, Hong Kong. I built a 5 strangers ages machine engine, which achieved 97.5% accuracy, verified by a 200 ages test suite for View Hong Kong address. A key innovation for this project is the intelligent data agent, also called the data refined agent. I built this agent with the Google Agent Development Kit, follow the MCP protocol. It used the local LLM to clean and normalize missing unstructured building data. Unlike traditional fast root ETL scripts, this agent works without strict predefined route. It also creates the full audio track and data limits for every transformation, which is the critical for the PTPO compliance. The second core part is the GIS and the spatial intelligence. I built the module on the PostgreSQL with the PostGIS extension, which is designed for connective geospatial data processes. I create optimized stranger extension index, which might spatial queries 16 to 18% faster. On the far end, user can explore building on the 2D and 2.5D maps. There's no just visualization. It is the spatial decision engine for the building rat assessment. The verified geospatial queuing time is under 125 milliseconds. Third, the AI assess defect inspection module. I fine-tuned the Euro 11 deep learning model for the AI building crack distinction. I built this as an independent microservice with the full fast API endpoint. It returns the exact location or the defect. Press confident scores for each detection a crack. So we had corrected this column. For cloud deployment and the enterprise future, the full system is fully containerized with the Docker and the deployment on the Google Kubernetes engine on the GCP. I designed and the 3-layer constraint system, which reduced database load by 17%, and there are over 13 RESTful API endpoints with the full automatic OpenAI documentation. I also implement enterprise-grade security feature, including JWT and the AWK augmentation, rack limit, and the full unitaries and military. Now, let's look at the verified performance result and finally document in my FYP final report. First, the aggregate database query time is under 100 milliseconds. The adjustment chain engine has the 17.5% accuracy. The aggregate API response time is under 200 milliseconds for the 94% for regular requests. And finally, the serverless design cut idle running cost to almost zero, which is the key engineering to choose for real-world production use. During the development, I faced several key challenges. First, build the practical solution for each. First, the initial adjustment chain rate was only 16%. I built the file structured machine engine and improved the accuracy to the 97.5%. Second, slow the database query. I add structured index and the 3-layer cache system, which delivered a 10x performance improvement. Third, machine understanding building data was hard to process. I built the intelligence data engine with the LLM use the Google ADK to enable flexible view-free data process. And finally, high count ideal cost. I use the serverless auto-scaling design, which cut ideal cost to near the zero. Limitation of the project. First, the AI module is correctly limits the surface crack detection only. It cannot analyze the real characteristics for defect. Second, data sources are limited to only Hong Kong government open data, limited by BDPO privacy regulation. For the future roadmap, I will explain the AI capability to more defect detect to raw cases analyze, integrate more BDPO corporate data source, complete the commercial future, and developers AI, not AI, mobile application. Now, my personal core contribution to this good project, which make up 17% of the total work. I design and implement the full system architecture. I built the end-to-end data pipeline about ETL and the intelligence data engine. I complete the spatial data design, database design, and the performance optimization, and fine-tune the Euro 11 model into the production-ready service. I also implement the full GCP cloud deployed or expression grade feature and complete VUE for an application. To conclude, let's summarize the project in the three key ping pong. First, this project shows real ping pong in Hong Kong's building expression and properties data subtle. Second, I delivered a complete enterprise-grade end-to-end platform, creating data integration, spatial intelligence, AI detection, and cloud deployment. Third, all core project objects are fully met with the summarizable performance result. Then apply the cloud and the data center administration principles we've learned in the programming. I would like to give a special thank you for my supervisor, Mr. Kitchen, and Mr. Harry, and Mr. Cyrus, for his great things and support my project and my study life. Thank you to the Hong Kong government for the open data source, and thank to the school for the lab and the resource support. And last, thank you all for your time. the 522 develop. The beat is the good level. Okay, I will upload the two images. These two images show the building's exterior and the photos of the crack. Those please note a crack does not actually exist in the reality. Crack image upload. It's very fast to get the result. You see it? It's run entirely on CPU, making it highly cost effective. Okay, we to generated the report. The report is generated using the DeepShape API and with the data is done. So we see the report and translate to the English. Try again.